This is section 1.4, so this is just an introduction to identities. Now, identities is something that will be true every single time. If you look at this first slide, all of these formulas, I need you to memorize them. Now, they are all located on your blue Things to Know and Understand formula sheet, so you're going to have them available to you during class and stuff. But in the end, this is going to be something that you need to know. They're really nice, they're very helpful, but we really need to know. So something that's simple, if you don't know, understand what an identity is, it can be something as simple as this. If you know 2x equals x plus x, how do I know that? Well, it's true every time. If you plug anything in for x, okay, 3 plus 3, well, I know that's 6 on the right side. Well, 2 times 3 is also 6. So it will be true every single time. That's what an identity is. So these formulas are relationships that will work every single time. Now it's just going to be hinging upon what the problem is given. So these are a couple that you'll use, and then here's the rest of them. Okay, so we have Pythagorean identities, equivalent forms, and then the simple ones on the previous page, the ratio identities and reciprocal identities and things like that. Just a quick note, this is sine squared theta. This is how we denote it, so there's no parentheses. But it actually means like sine theta, whatever it happens to be, quantity squared is the exact same thing. So I just want to preface that. So this is exactly like saying 1 plus tangent theta quantity squared, but it's just cleaner to write it without parentheses. So that's the idea. So sine squared plus cosine squared equals 1. That's the biggest one we need to know and understand. That's going to be used a lot. But think about this as we know that sine is y. Y squared plus x squared equals 1 squared, which is r squared in our unit circle. So that goes back to the picture that we drew way back in the day where it was x and y and r. And if you do Pythagorean theorem, x squared plus y squared will be r squared. So that's the idea. That's where that comes from. And then everything goes off of the Pythagorean identity. It really does. So let's just jump to a couple problems and see if we can figure out what's going on. So if I say use the reciprocal identity, so you might want to page back. Where's the reciprocal identities? It's the first slide. And what does secant equal? Well, I want to find secant. The reciprocal identity says that secant theta is equal to 1 over cosine theta if I happen to know what that is. Well, I know what cosine theta is. So I can say that secant theta equals 1 over root 3 over 5. Well, how do I simplify that? I can multiply top and bottom by the reciprocal. These cancel. I'm left with 5 over root 3. Now, most of you are like, well, duh, Mr. Wilson, you told me that I can go to secant by just flipping cosine. Well, that is true. That is exactly what you're doing. But this is using the identity, so I just wanted you to show me, or show that. So now you just need to multiply root 3 top and bottom. Okay, so the rule is called reciprocal identity. You literally find the reciprocal. That's the idea. But that's just using the formula as it stands. Now, some are like, do I have to use that formula? No, you don't. If you know that secant theta is just a flip-flop or the reciprocal of cosine, please do that. Do not make it any more work than it has to be. Okay? The ratio identities. Now, tangent. We know that tangent is y over x. Okay, so if you know that, what's y every time? Sine. What's cosine, or x every time? Cosine. So if you look at your formula, tangent is sine theta over cosine theta. So to do that, if you know the actual values, this is going to be pretty nice, because all I have to do is just dump in what sine is over what cosine is. So sine is 2 over root 5. And it's divided by, what's cosine? 1 over root 5. And how do I simplify fractions on the bottom? You could multiply by the reciprocal to the top and the bottom. These are all gone. So then if I look at them just on the top part here, the root 5's also cross, so your answer is simply just 2 over 1. So some of these literally happen and go as quick as that. And I'm probably even making it longer than it has to be. Okay? So if I give you cosine and I want to know what cosine squared is, it's not any more difficult than you want it to be. You just square it. So cosine squared theta is just whatever cosine was squared. So 1 squared over 3 squared is 1 over 9. So that also can be that simple if you need to use the squaring mechanism at all. Okay, so let's look at a couple others. We have sine, and I give you cosine, and I want to find cotangent. So cotangent is now your, what? X over y. So your cosine over your sine. So cosine theta is equal to negative 5 over 13 divided by sine is negative 12 over 13. Now if I multiply all the bottoms are gone. 2 negatives make a positive. The 13's cross out, so I'm left with 5 over 12. That's simple. Okay, so there's your ratio identities at their finest right there. So that's kind of how that works. Hopefully we're okay up to that point. So it says use the forms of the Pythagorean theorem. Alright? Use the forms of the Pythagorean theorem to find out what cosine theta is if sine is 4/5. Now what we could do is draw a picture if you really wanted to. That's the easy way. But what happens if I only give you the identities? So what you need to do is go to the equivalent forms of the Pythagorean identities. Now I want to find cosine. Okay? So this thing says that cosine theta equals plus or minus the square root of 1 minus sine squared theta. Now where does that come from? It comes from sine squared theta plus cosine squared theta equals 1. Can you solve for cosine? Well, I would subtract this guy over. There's your 1 minus sine squared theta. And then you have to take the square root. And when you take the square root, you have to do plus or minus every single time. Now, we'll talk about what happens with the plus or minus part in a second, but that's where the formula stems from. Now, what we need to do then is solve for this. Now, do I know what sine squared theta already is? I do, because I know what sine is. So as long as I know what sine is, I'm going to go out here and say sine squared theta equals 4/5 squared. So sine squared theta is 16 over 25. So how does that help me out? I now can dump that in. I can say that cosine theta equals plus or minus the square root of 1 minus 16 over 25. So that's same as saying plus or minus the square root of, now what happens? I can change 1 to 25 over 25. So 25 minus 16 would be 9 25ths. So if I take the square root of that, plus or minus 3/5 is my cosine theta. Now here's the problem. I don't know if it's plus or minus. Here's where the whole termination thing happens. Where is this thing ending? So now, I usually don't like saying this, but I'm going to give you what I would actually like to do to solve this problem. I know I'm in quadrant 2. 1, 2. So I'm going to put a triangle in here. Okay? And on my triangle, I'm given that sine is 4/5. Sine is opposite, or the y value. The hypotenuse is 5. What does the x have to be? Hopefully you recognize that it's 3, 4, 5. Okay? If you don't, use Pythagorean theorem and say x squared plus 4 squared equals 5 squared. So then x squared plus 16 equals 25. 25 minus 16 is 9, and then it's plus or minus 3. Well, this 3 here need to be positive or negative. We're left of the origin on the x-axis. It must be negative. So you need to use the negative sign. Now, what would have been actually easier to solve this thing? Doing what I just did. Draw yourself a picture. If I give you sine and you know what's in quadrant 2, draw your picture. Fill in the missing triangle and then do what I'm asking. Cosine theta is x over r. Okay? And it's going to be negative 3 over 5. So that is your answer. Excuse me, I just about killed my microphone here. And this is also negative 3 over 5. Okay? This part is using your formulas. So some of you love having formulas and knowing them. Well, you're going to have to memorize this one. So what might actually be easier for you to do, if you can get in the habit of understanding how to draw a picture, this problem becomes a lot easier. Because you can just put in sine theta is 4/5 opposite over hypotenuse. You can find the missing side, and then you can go back and reboot and say, okay, cosine theta is your x over your r, the negative 3 over 5. Okay, so that is the way that you can draw the picture. So you're doing one more like that, but this time I'm just going to draw the picture. I'm not even going to do the other one. Okay, theta is not in quadrant 2, but I know cosine is negative because of this. Well, cosine is x over r, and if it's negative, where is x negative? It can't be in quadrant 2, so it must be in quadrant 3 because we're to the left. Okay, my theta will always be between my terminal side and my x-axis. And now what is x? Negative 1. Hypotenuse is 3. So what does that end up making my y value? Well, negative 1 squared plus y squared equals 3 squared. 1 plus y squared equals 9. Subtract 1. Y squared equals 8. And if I take the square root, y equals plus or minus the square root of 8. Well, I know it's root 8. Is this up or down? If you think of the y value, I'm down. So it must be negative square root of 8. And then it just says find the remaining trig ratios. So you just have to find sine, cosine, tangent, and then do the other ones. So this should be relatively quick and easy. So sine theta, y over r, opposite over hypotenuse, negative square root of 8 over 3. Cosine theta, I already have that. Tangent theta, opposite over adjacent. So negative root 8 over negative 1. What is negative root 8 over the negative 1? It's square root of 8, but I realized I forgot to do this, so I'm not going to rewrite it, but square root of 8 should be written as 2 square root of 2. So rewrite all of these as 2 square root of 2. I just don't want to waste any more of your time. Okay? And then, what are my 3 reciprocal identities? Okay? So I'm going to have to just flip them. So cosine or cosecant theta is going to be negative 3 over, I'm going to write 2 root 2 now. But I can't have that. So I need to multiply by square root of 2 over the square root of 2. So it's actually equal to negative 3 root 2 over 4, because square root of 2 times the square root of 2 is 2, and I have to multiply by this 2 that's sitting there. So that's your cosecant. Secant theta is going to be just negative 3 over 1. So that's pretty easy. And then cotangent, this is over 1, right? So it's going to be 1 over the square root of 8, but it should be rewritten as 2 root 2. So I also have to do the root 2 idea. So it's going to be root 2 over 4. Alright, so that's how you find the other trig functions given one specific thing. So I'm going to give you one of the trig functions. You have to figure out what quadrant to draw your picture in, find the missing side, and then it's just like every other section that we have done. So that is that section. So those are the basic identities. Please don't freak out if you think this is way overwhelming right now. We will work on them in class quite a bit at the end of this week and early next week. So hopefully you have a wonderful night.